Hi, welcome to the screencast of my third year project, the development of a computer vision method to measure Parkinson's tremor amplitude, supervised by Dr. David Wong. Tremor is an involuntary shaking movement of one or several parts of the body. It is characterized by its frequency and its amplitude, much like a wave. It is one of the symptoms of Parkinson's disease, which almost 3% of the UK population are diagnosed with in their lifetime. Sadly, Parkinson's disease has no cure, making research into improving its care all the more important. There are three types of tremor which are present in patients with Parkinson's disease. Resting tremor, which occurs in a body part that is relaxed and supported against gravity. Postural tremor, that occurs in a body part that is voluntarily held against gravity. And a third type, kinetic tremor. My project focuses on measuring resting and postural tremor. The severity of a patient's Parkinson's disease can be assessed using a scale known as the Movement Disorder Society-sponsored revision of the Unified Parkinson's Disease Rating Scale, or MDS-UPDRS for short. The scale is designed to be used in a clinical setting as well as in research. The UPDRS is a large document considering various aspects of a patient's Parkinson's disease, including the measurement of the amplitude of their tremor. Amplitude is categorized with a rating, starting at 0 indicating no tremor and going up to 4 indicating the most severe tremor. The gold standard for measuring both the frequency and amplitude of tremor is through the use of an accelerometer. This is strapped to the dorsum of the hand like so, measuring the hand's movement. However, accelerometers are specialist pieces of equipment and are only available for patients in certain settings. This leads to the objective of my project, to develop a method to measure the amplitude of hand tremors driven by computer vision. This would require no specialist equipment, just a smartphone to record the video. However, before developing my method, I needed data to test it with. Measuring tremor amplitude using computer vision is more complicated than measuring tremor frequency, as more context surrounding the video needs to be known. The distance between the camera and the hand needs to be known, as otherwise there is no way to tell the difference between a small object that is close to the camera and a large object that is far away. Therefore, videos of hand tremors need to have accompanying depth data. I could not find an existing dataset of hand tremors with depth data, so I had to create my own. However, I couldn't start collecting data before first developing a means of measuring depth. Modern iPhones have a camera with an integrated depth sensor, known as the TrueDepth camera. I developed an iOS app using the Swift language, which utilizes this sensor in order to take depth measurements. Here you can see a demonstration of the app in use. When the Measure Depth button is pressed, the app takes multiple depth measurements and obtains their average to get an accurate result. This works well at a variety of distances, even as close as 25 centimeters or so. Following this, I could start collecting data. However, before collecting videos of hand tremors, I recorded a set of videos of an idealized model of a hand, that being an oscillating pendulum. I did this so that I could write a prototype method which measures the movement of a simple object before increasing the complexity of the problem with the introduction of hand detection. Pendulums move in a simple and repetitive manner, making them a good simple model of a tremoring hand. This prototype was written in Python, using OpenCV to implement computer vision algorithms. A computer vision technique known as blob detection was used to find the location of the pendulum in each frame and track it throughout the video. Amplitude was then calculated by subtracting its rightmost position from its left. This only obtained the amplitude in terms of pixels. To convert this measurement to centimeters, the depth measurement is used to calculate the physical size of the video's field of view, and thus the size of each pixel at the depth of the pendulum. With this, the amplitude of a pendulum's oscillation is calculated. With the prototype complete, I began collecting videos of hand tremors. These were recorded at a variety of depths, with a variety of different tremor amplitudes. Videos of resting tremors, like the one you can see here, were recorded. Additionally, videos of postural tremors were recorded. In total, 66 videos were collected, each with an accompanying depth measurement. Finally, the development of the tremor amplitude measurement method began. This built upon the prototype, also being written in Python. Blob detection was replaced with hand detection, implemented using MediaPipe. Here is a demonstration of how the method is used. First, I type in the file path of a video. I then type in the video's accompanying depth measurement. After this, the type of tremor needs to be entered. The video which I've chosen depicts a resting tremor. Finally, I select the tracking landmarks. For this example, I have chosen the pip joints. The program then displays the configuration for me to check. Once this is confirmed, hand tracking will begin. The landmark placement from hand tracking is displayed in real time on the left of the screen. You can see quite how accurate the landmark placement is, even when the video blurs slightly. Fast forwarding to the end, the waveform of the hand's movement is presented, and the results are displayed in the command line. Tremor amplitude is calculated by differentiating the waveform and taking the median of the distances between each neighbouring peak and trough. You can see it on the waveform, marked as a dashed line. The method can also measure postural tremor in the same way as I just showed for resting tremor. How well does my method perform? Overall, tremor amplitude is measured with a high accuracy. The amplitude of resting tremors, an example of which can be seen, is measured with a mean error of 3% when recorded at a depth of 50 centimeters. The amplitude of postural tremors, like the one shown here, is measured with a mean error of 5.3%. Small tremors can be measured accurately too. For example, resting tremors between 0.15 and 1 centimeter are measured with an error of just plus or minus 0.05 centimeters on average. The method is also excellent at identifying when a video depicts no tremor. Tremor is still accurately measured even when the hand moves around in the video, because amplitude is measured as the median of the size of each individual tremor, rather than just the range of movement. This particular example shows this very prominently. How does my method compare to other ways of measuring tremor amplitude? I'll start by comparing it to the MDS UPDRS. Both methods are contact-free and don't require specialist equipment. However, my computer vision method has the potential to be used remotely, whereas the UPDRS requires an in-person consultation, as evidenced in a paper which considers its practicality for remote consultations. In addition to this, my method gives an objective result, whereas the UPDRS is based upon subjective observation of tremor. Additionally, I can compare tremor measurement using computer vision to measurement with an accelerometer. Computer vision, again, is contact-free and does not require specialist equipment, whereas an accelerometer is itself a piece of specialist equipment and is not contact-free. Both methods are objective, obtaining an exact value for amplitude. Accelerometers have been proven to be accurate and reliable, whereas more research into computer vision amplitude measurement will be needed to fully understand how well it performs. My method is definitely not perfect. Tremor is only measured in 1 degree of freedom of movement, out of a possible total of 6. Further translational movement, as well as rotational movement, could be accounted for in order to obtain a more comprehensive understanding of tremor. On top of this, only 1 depth measurement is taken per video, which has the potential to introduce error as not every point in the hand is equidistant from the camera. There is the potential to improve this, for example by recording a point cloud of the hand. This can be done using the same TrueDepth sensor that I used in my project. This video of a point cloud that you can see, for example, was recorded using said sensor. Despite the potential for improvement, my method performs well, and I think that computer vision tremor amplitude measurement has the potential to help to improve the quality and accessibility of Parkinson's care in the future.